Welcome back to the virtual class of Milestone College. This is AFM Yusuf, Assistant Professor, Department of Chemistry, Milestone College. Dear students, today I am going to teach you the creative questions of organic chemistry, and this is an aromatic part of organic chemistry. 3P, in the presence of iron catalyst, 400 degree centigrade temperature converts into Q, and Q reacts with chlorine in the presence of ferric chloride to produce R, and at 350 degree centigrade temperature, 150 atm pressure, R compound reacts with sodium hydroxide and then hydrochloric acid to produce S compound. Again R reacts with ammonia in the presence of cuprous oxide at 200 degree centigrade temperature and high pressure to produce T compound. Here P is acetic hydrocarbon with 2 carbon atoms. My dear students, it is stated that acetic hydrocarbon is actually alkyne 1. As it is acetic hydrocarbon with 2 carbon atoms, of course indicates ethyne, CH triple bond CH. Actually P indicates ethyne. So dear students, I can write here ethyne, CH triple bond CH, and we know that if ethane gas is passed through the iron tube at 400 degree centigrade temperature, benzene is produced. So Q compound is actually benzene. This P compound, and in the presence of ferric chloride, benzene reacts with chlorine to produce chlorobenzene. This chlorobenzene reacts with sodium hydroxide at 350 degree centigrade temperature and 150 atm pressure to produce sodium phenate. Then sodium phenate. This sodium phenate reacts with hydrochloric acid to produce phenol. Actually S compound indicates phenol, and again at 200 degree centigrade temperature, in the presence of cuprous oxide, chlorobenzene reacts with ammonia to produce aniline. So I can say here T indicates aniline, S indicates phenol, R indicates chlorobenzene, and Q indicates benzene, and P indicates ethyne. Of course ethyne gas. Okay, on the basis of this stem, the Sinon question, an applicable question is, though compound T, though compound aniline is basic in nature, but compound S, compound phenol, is acidic. Explain it. Number G, in the nitration reaction of compound S, nitration reaction of compound phenol produces orthopara products, produces orthonitrophenol and paranitrophenol, but compound T, aniline, produces matter product only. Analyze it. That's all this creative question. Now I am going to describe the question one by one. Now the question now C. T compound, already I have told you, T compound is aniline, T compound is basic, but compound is, phenol is acidic. Explain it. Dear students, first you have to write the real reaction according to the stem. Then you have to describe phenol is acidic in nature, and then you have to draw the resonance figure. From the resonance, it is seen that due to the resonance, oxygen of OH group of phenol becomes positively charged. As a result, the bond pair electrons between oxygen and hydrogen are pulled to oxygen due to the positive charge of oxygen. As a result, the hydrogen and oxygen bond is break, and hydrogen atom can be released as H plus ion. And according to the Protonic concept of acid, the substances which can donate proton to another substance is called acid. Here, due to the resonance, phenol can donate H plus ion, proton, to produce phenoxide ion and H plus ion. Dear students, this phenoxide ion is also stable, and it gains stability due to the resonance. So phenol is acidic in nature due to the donation of proton. It also reacts with base. Example, phenol reacts with sodium hydroxide to produce sodium phenate plus water. That's why phenol is acidic in nature. Again, aniline is basic in nature because amino group, nitrogen of amino group of aniline contains a lone pair electrons. According to the Lewis concept, the chemical substances which can donate lone pair electron to another substance is called base. Here, aniline, nitrogen of aniline contains a lone pair electron which donates to proton to produce anilinium ion. As an example, aniline reacts with hydrochloric acid to produce anilinium chloride. That's why aniline is basic in nature. That's all about the answer of question C. In the question on D, it is given compound S, phenol, is orthopara director. Actually, phenol produces orthopara products in the nitration reaction. Now, if I show you the nitration reaction of phenol, this is phenol. According to the stem, this is actually compound S. In the presence of sulfuric acid, phenol reacts with nitric acid to produce orthonitrophenol. Orthonitrophenol and paranitrophenol. Paranitrophenol. Dear students, all of you know that 1, 2, 3, 4, 5, 6. The position number 2 is known as ortho and position number 4 is known as para. That's why this is orthonitrophenol and this is paranitrophenol. If you observe this reaction very specifically, you know that each of the corner contains hydrogen atoms, and I can write the nitric acid as, this is partial structural formula of nitric acid. This hydrogen atom combines with OH of nitric acid to produce water, and this hydrogen atom is actually replaced by nitro group to produce orthonitrophenol. And again, this hydrogen atom of para position combines with OH group of nitric acid to produce water, and the hydrogen of para position of phenol is replaced by nitro group to produce paranitrophenol. And my question, why is nitro group attached with ortho position and para positions of phenol? Because in the resonance, through the resonance, the OH group of phenol supplies the lone pair electron to the benzene ring and increases the electron density of benzene ring at the ortho and para positions respectively. That's why the electrophilic reagent or the electrophile attacks to the ortho and para position to produce ortho products, orthonitrophenol and paranitrophenol. Dear students, electrophile means the group which loves electron. As the electron density of ortho position in benzene ring is increased, that's why nitro group attacks to the ortho position of phenol. And also electron density of para position of phenol is increased due to the resonance. That's why nitro group, electrophile, attacks to the para position of phenol to produce para product, I mean para nitrophenol. T compounds, I mean aniline, also increases the electron density at its ortho and para position through resonance like phenol. That's why you can think that in the nitration reaction, aniline should produce orthonitroaniline and paranitroaniline like phenol, but it is not happening. Actually, I would like to show you in black and white. Aniline in the presence of sulfuric acid, aniline reacts with nitric acid. This is actually nitric acid to produce orthonitroaniline and paranitroaniline. It should be produced. Actually, the reaction is not occur like this. Actually, I would like to say you, aniline should produce orthonitroaniline and paranitroaniline like phenol, but it is not happening. It is not happening. It should happen because aniline shows resonance like phenol. But now my question, why aniline does not give orthonitrophenol and paranitrophenol in the nitration reaction? I mean, why does aniline not ortho and para products in the nitration reaction? Because aniline reacts with sulfuric acid initially. This is sulfuric acid, H2SO4, this is sulfuric acid, and this is actually proton of sulfuric acid. You know that nitrogen atom of aniline contains a lone pair electron. This lone pair electron donates to the proton of sulfuric acid to produce anilinium ion. Anilinium ion. This anilinium ion is actually only meta director. That's why it reacts with nitric acid to produce meta nitroaniline. Actually, I would like to say you, anilinium ion pulls the delocalized electron from the benzene ring. As a result, the electron density of meta position is increased. That's why nitro group of nitric acid attacks to the meta position of aniline to produce metanitroaniline. This is the reason of production of metanitroaniline, though it should produce orthonitroaniline and paranitroaniline. That's all about the answer of question number D. My dear students, you need not show this resonance figure, but you can write only the fact in word. You can write here, aniline also shows resonance figure like phenol. That's why it should produce orthonitroaniline and paranitroaniline, but in really it does not happen because aniline initially reacts with sulfuric acid to produce anilinium ion. This anilinium ion is metadirectal, that's why it reacts with nitric acid to produce metanitroaniline. That's all about this creative question. Dear students, you can study the preparation of TNT from benzene. From benzene to toluene, then from toluene to TNT, trinitrotoluene. This is an explosive substance. This is a very important question for your upcoming exam. Again, you can study the resonance, the comparison of reactivity in electrophilic substitution reaction between toluene and nitrobenzene. And you can also learn about the preparation of paracetamol from phenol. Those are very important questions for your upcoming exam. No more today and goodbye, my dear students.